think that's long enough.
Joseph John Thomson was born in 1856 in Chester Hill, Manchester, England. His mother came from a local textile family, and his father ran an antiquary bookshop. His father died when Thomson was 16 years old. The death of his father blocked arrangements for him to enroll in an apprenticeship. This set Thomson on an academic track.
J.J. Thomson was a brilliant child at the age of 14. He studied engineering at University of Manchester, known as Owens College at the time. Later, he moved on to Trinity College in 1876 and obtained his bachelor's in mathematics and master's in 1883. He was one of the top scholars in his class and became one of the senior professors of physics at Cambridge College in 1884. In 1818, he became the master at Trinity College, Cambridge, where he remained until his death. He was awarded the Nobel Prize in 1906 in the recognition of the great merits of his theoretical and experiments investigation on the conduction of electricity by gases. Thomson was knighted in 1908 and appointed to the Order of Merit in 1912. Order of Merit is a recognition of service in science, arts, literature, or promotion of culture.
Joseph John Thomson was credited for the discovery of electrons and also isotopes. He conducted 3 experiments with cathode rays, leading him to the discovery of electrons. In his first experiment, Thomson investigated that the idea that the negative charge in the cathode rays tube could be separated by using a magnetic field. He constructed the cathode ray tube with a metal cup of the electrometer, away from the undeflected path of the cathode rays. When the tube was activated, the electrometer showed no charge unless the beam was magnetically deflected towards the metal cup. He concluded that the negative charge always followed exactly the same path as the cathode rays, and was therefore a property of the cathode ray. In his second experiment, he investigated whether or not the rays could be deflected by an electric field. He constructed a cathode ray tube with an almost perfect vacuum and coated one end with phosphorescent paint. He found that the rays did bend under the influence of an electric field in the direction indicating a negative charge. In his third experiment, he measured the mass-to-charge ratio of the cathode ray by measuring how much they were deflected by a magnetic field and how much energy they carried. He found that the mass-to-charge ratio was over 1,000 times lower than that of a hydrogen ion, suggesting either that the particles were very light or very highly charged. In conclusion, cathode rays were indeed made of particles which he called corpuscles, and these corpuscles came from within the atoms of electrodes themselves, meaning that the atoms are in fact divisible. The corpuscles discovered by Thomson are identified with the electrons, which had been proposed by G. John Stoney.